In previous sections, we have looked at using Pythagorean theorem to solve two-dimensional object problems that use various geometric shapes, such as squares, rectangles, rhombuses, and circles. Well, today's lesson, we're going to look at using Pythagorean theorem to solve three-dimensional problems. For example 1, a 50-meter rope is attached inside an empty cylinder wheat silo of diameter 12 meters as shown. How high is the wheat cylinder? So let's label in our diagram what we want to figure out height. Now notice if I look inside the cylinder, we have formed a right triangle. So let's bring this right triangle down so we can draw a little nice picture so we can see what we're working with. Labeling our information on this new right triangle, have my height of h, 12 meters across the diameter, and this rope of 50 meters long. We need to solve for h, so we just use Pythagorean theorem. H squared plus 12 squared is going to equal to 50 squared. And now I'm just going to simplify this down and solve for the h. That h is approximately 48.5 meters. And then of course we write our final answer as a sentence. You have now completed your first three-dimensional word problem. Now for example 2. Not every word problem is going to give you the diagram. Sometimes you have to draw the diagram yourself. That's what's happening in the second example. The floor of a room is 6 meters by 4 meters. And its height is 3 meters. Find the distance from the corner point of the floor to the opposite corner point of the ceiling. So here's our diagram. Now notice I've drawn our room. It's a 4 by 6 base floor with a height of 3 meters. And I've labeled some important parts on here. This slanted line AD, which I labeled Y, is what we want to figure out. That is the distance from the corner point on the floor to the corner point on the ceiling. Now, in order to do that, I notice it forms a right triangle, but I have two missing lengths, the x squared and the y squared. So I need to first solve for x before I can figure out y. So I look at this bottom triangle, and I can see that I have this triangle BCD, and then I want to solve for x first in this triangle BCD, and then I'm going to use our measurement of x into my triangle ABD. For the bottom triangle, I have 4 squared plus 6 squared equals x squared. Now I'm going to simplify this down using our Pythagorean theorem. I end up with x squared is equal to 52. Now you can go on to solve for x and get x is equal to the square root of 52, but I'm going to stop here because I know I want to use Pythagorean theorem for triangle ABD, and I'm going to need x squared in there as well. So I'm just going to stop at x squared here. Now looking at triangle ABD, I have 3 squared plus x squared is equal to y squared. In place of this x squared, I'm going to plug up what I figured out earlier that x squared is equal to. So I'm going to put 9 plus 52 equals y squared. And I'm going to simplify down and solve for the y. When I end up with y is approximately 7.81 meters. Then I'm going to answer my question in a sentence form. The distance from a corner point on the floor to the opposite corner point on the ceiling is about 7.81 meters. For our last example today, we are given a pyramid of height 40 meters, has a square base with edges 50 meters. Determine the length of the slant edge. So again, we need to start by drawing a diagram of what's going on. First thing I should do is recognize on my diagram, what am I trying to find? And I'm trying to find the slant height on our pyramid, which I've labeled S for slant height. Now notice in this dark pink triangle, I have two missing sides. I have X and S. So that means I need to solve another triangle first before I can solve for the slant height. I'm going to do this by looking at this bottom triangle. Happens to be an isosceles triangle. And I'm going to solve for X in this triangle. So looking at the triangle, I'm going to draw my picture over here so you can see which one I'm looking at. Use Pythagorean theorem to solve for x. So that means I have x squared plus x squared is equal to 50 squared. Simplifying this down, Therefore, x squared is equal to 1,250 meters. Now I'm going to stop here at x squared because I know I'm going to use it in the Pythagorean theorem for the dark pink triangle, and so I'm going to leave it as a square term. Now looking at this triangle, again, I'm going to draw a picture of what I'm looking at so they can see which one we're solving for. Using the Pythagorean theorem, I'm going to get x squared plus 40 squared is equal to s squared. And I already know that x squared is 1,250, so I'm going to plug that in, and 40 squared is 1,600. And then I simplify this down, and I get 2,850 is equal to s squared. So s is equal to plus or minus square root of 2,850. So s is approximately 53.4 meters. Finally, I'm writing my final answer as a sentence. The slant height of the pyramid is approximately 53.4 meters.